Hello everyone, here is a somewhat tricky question from the basic concepts of chemistry. The reason I say this question is tricky is because if we don't understand the concept of stoichiometric moles, then it is difficult to solve this problem, though it is easy to solve. Let me read the question first. 1 gram of an impure sample of magnesium carbonate containing no thermally decomposable impurities on complete thermal decomposition gave 0.44 gram of carbon dioxide gas. In that case, what is the percentage of impurity of the sample? So, they are asking the impurity of magnesium carbonate. 1 gram impure sample gave 0.44 gram of carbon dioxide. Here, the most important thing that we have to note is containing no thermally decomposable impurities. That means the products are pure, impurity remains as an impurity. Impurities are not decomposing. So, magnesium carbonate upon heating will give magnesium oxide and CO2. The reaction is already balanced. In that case, how we write the stoichiometric moles? Stoichiometric moles is 1 by whatever is the coefficient we have here, that we bring it down. Number of moles of MgCO3, here 1 by 1 number of moles of MgO, here 1 by 1 number of moles of CO2. We do not have two reactants here, we have only one reactant, and therefore, whatever is being asked, that we can equate. So, we do not have to worry about limiting reagent and all here, because we do not have A plus B, we have only A, and therefore, we do not have to worry about the concept of limiting reagents here. So, we can directly equate 1 by 1 number of moles of MgCO3 with the 1 by 1 number of moles of CO2. This just simply means that if you have 1 mole of MgCO3, you will get 1 mole of CO2. That is what it means, isn't it? Here 1 gram of an impure sample of magnesium carbonate, but is the carbon dioxide has impurity? No, the carbon dioxide is pure, that is 0.44 gram. And therefore, let us find the number of moles of carbon dioxide first. So, number of moles is equal to mass divided by molar mass. Mass given is 0.44 gram. Molar mass of CO2 is, this is 12 plus 2 times 16, and therefore 12 plus 32, that is 44. So, 44 gram per mole. Therefore, this is 0.01 mole. So, we should have, if the sample is pure, then 0.01 mole of MgCO3 should give 0.01 mole of CO2. That is what it means. Therefore, let us find the mass for 0.01 mole of MgCO3, and for that we need the molar mass of MgCO3. So, for Mg it is 24, carbon 12, 3 times oxygen 16, and therefore, this will be equal to 84 gram per mole, the molar mass of MgCO3. So, 0.01 equal to mass divided by 84 gram per mole, here mole, this will cancel out, and therefore, the mass is 0.84 gram. So, if we have 0.84 gram of pure sample, that would give 0.44 gram of CO2. But what was the weight given in the question? It was given 1 gram, and therefore, the impurity is equal to 1 gram minus 0.84 gram, that is 0.16 gram. So, in terms of percentage, if you want to talk about, then multiply by 100. Therefore, 16% is the impurity. Therefore, option C is correct. I know some of you might still be wondering like how come 1 gram of magnesium carbonate gave 0.44 gram of CO2 and 0.84 gram of magnesium carbonate also gave 0.44 gram of CO2. See, when we say 1 gram, it is an impure sample, but the product is pure. This is pure. CO2 is pure. It is clearly mentioned that containing no thermally decomposable impurities. That means the product is pure. When we spoke about the stoichiometric moles, we have to equate with the pure product with a pure reactant. That's what we did, through which we found the weight. If the sample was 100% pure, then the actual weight should have been 0.84 gram. But do we have 0.84 gram here? No, we have 1 gram. So, what you need to understand here is, if the impurity is increasing, then the total weight of the sample is going to increase. That is what you need to understand here.